Physicists are perhaps the worst people to watch a movie with, especially a sci-fi or fantasy movie, and I'm about to show you why. Whenever you give us some numbers and values, then we're going to want to use those values to compute the possibility or improbability of things from happening. Here, this is from the Lord of the Rings books. Tolkien writes that Legolas says this about a friendly army in the distance. There are 105. Yellow is their hair, and bright are their spears. Their leader is very tall. Their riders are little more than 5 leagues distant. So 5 leagues is an actual unit of measurement, which is about 28,000 meters away. And Tolkien is saying that Legolas can see all of these riders from that far away. Now, we wouldn't be able to see them. Of course, we would see perhaps a little dot or a blurry mess. But assuming that Legolas the elf is subject to the laws of physics, then we can find out if he should be able to see them based on the Rayleigh Criterion. So his eyes have a certain size, and they have to be big enough in order to resolve and count that there's 105 riders. So breaking this down with the Rayleigh Criterion in mind, this passage means that Legolas' eyes were able to resolve the riders, and we'll say they're separated by about 30 centimeters from one another using his optical instruments, which are his elf eyes. And we can only assume that they're like humans in that they have an n equals 1.36 unitless value. That's the index of refraction. The riders are 5 leagues away, and as I said, that's 28,000 meters. So what minimum pupil diameter would be required for his eyes to resolve the neighboring heads? And they say that they have yellow in their hair, which has a wavelength of 570 nanometers. For reference, by the way, a human pupil is about 4 to 8 millimeters in diameter. So if we draw a picture, it looks something like this, right? Of course, with the distance not quite to scale here. Legolas's eyes have some sort of a diameter. We'll say D for that diameter. And he's resolving the image of two people which are 28,000 meters away and 0.3 meters apart. When we are interested in resolution, we would be interested in the visual angle, the sort of angular distance between the two. So if Legolas is able to resolve them, then they would look something like this, where we have two separate heads per rider. But if his eyes are too small, then diffraction starts to take over and things get blurrier and blurrier until we cannot tell that there are two riders, in fact, or 105 or whatever he said. So at this point, all we have to do is recall the Rayleigh Criterion and try and analyze everything piece by piece. Now, one thing I do want to focus on though is this angle, right? So if you look at the picture, it might not really be obvious how to find that angle, given that our usual method is to use trig and to think about a right triangle. It's not obvious where the right triangle is here, but this distance, 28,000, is so much larger than 0.3 meters that we're definitely in the small angle approximation regime. There's many interpretations of this, but if you think about it, right, so this angle is very small, and the three angles in a triangle add up to 180 degrees. That means that these two angles are really close to 90 degrees. And this looks very strange. Triangles don't normally have two 90-degree angles. But they're almost 90 degrees, and that causes a lot of things to happen. This 28,000 meters, let me just call it L, is roughly the same as this other side of the triangle. And the angle theta is roughly equal to sine of theta, which is also roughly equal to tangent of theta. And so a lot of our arctangents, arcsines that we might normally need, we don't have to worry about them because they're all approximately equal to theta itself. And so opposite over hypotenuse or opposite over adjacent, they're about the same number. And this is fine so long as we use radians. So this does not work with degrees. It has to be in radians. If you're unsatisfied with the small angle approximation or using this, then what you can do is take this triangle and imagine that Legolas is looking in between the two riders, and so his line of sight is bisecting the two um, the line between the two riders, and so now we have these two right triangles, one like this, which is like half of theta. And you could do this problem in which you compute half of theta and then double it to put it into the Rayleigh criterion. I'm going to go ahead and use a small angle approximation. If it's unsatisfying to you, then you should compute it your way and see if it matches my way. So the Rayleigh criterion is theta minimum, as in the minimum angular distance, visual distance between two objects, has to be at least 1.22 lambda over d times n. The 1.22 might sound mysterious, but it's coming from some sort of solution of a higher math problem, which is not really important to us. It's just an approximate number that we'll take as a given rather than have to do an Airy disk formula, which is more complicated. So now we want to identify and make sure that we have everything we need. I think the easiest thing to see that we do have is the wavelength. We're interested in the blonde hair, and so this is going to be the 570 nanometers. 570 nanometers, or 10 to the minus 9. Nano sounds like 9, and so that's how I remember that 570 nanometers is 570 times 10 to the minus 9. N is the index of refraction inside the optical element, which is the eyeball here, and so that's 1.36 in units numbers. D is the diameter of the pupil, and we don't know what that value is, and so this is what we're aiming for. And theta minimum is going to be the angular separation as pictured here. And so we can find that with an arc sine. If you treat this, for example, as a right angle, then, or sorry, I should say arc tangent, opposite over adjacent, or an arc sine too, right, since this is 28,000. But the small angle approximation is pretty much saying that this theta is approximately equal to opposite over one of these adjacents or hypotenuse here. So 0.3 meters over 28,000 meters. And I got a value of 1.07, 1 times 10 to the minus 5 radians. Make sure your calculator's in radians, or else this will not work. If you do an arc sine or arc tangent, it won't work. You won't get the same number. Now we're looking for d, so let's do some quick algebra before we plug anything in. And so I see d on the denominator. That makes me want to multiply both sides and get rid of the theta by dividing it to both sides. And so d is going to be equal to 1.22 lambda over n times theta minimum. You just flip it. You flip the position of theta and d. Plug those values in, and I got that d is equal to, so we plug everything in, plug this for theta, plug in 570 times 10 to the minus 9, and 1.36, I got 0.0477 meters, or about 4.8 centimeters, 10 times as big as a regular human pupil. Now, perhaps Legolas is using some dimensional magic to change the size of his eye or something like that. Or maybe this n value is not really 1.36. Maybe Legolas has a much bigger magic elf value. Or maybe he wasn't described well by Peter Jackson, and maybe he looks a little bit more like this.